Welcome back, my fellow assassins, to another episode of the Dark Assassins podcast, the show that dives deep into not just technology, but the concepts, software, and procedures behind it all, and explains it so simply that even your grandma can understand it. As always, I'm your host, the Dark Assassin. So today we got another episode of Operation Core Dump. So I think we got a lot of good topics to cover in this episode, as well as a rant from yours truly. So with that being said, why don't we get started? So a couple episodes ago, when we were talking about WWDC and Apple's big reveal of their new silicon with the M2 chip, I mentioned a term that I realized I didn't define, and some of you might be scratching your head, what am I talking about? So we're going to cover that right now. So I talked about this idea of binning, or CPU binning, GPU binning, RAM binning, whatever. Any type of silicon-based chip uses this term called binning. So for simplicity's sake, I'll probably mostly just stick to CPUs, but I will throw, other things in here too. But just know this applies to anything silicon-based. So CPUs, GPUs, RAM chips, what have you, anything silicon-based, this thing binning applies to them. So basically, all of these silicon-based things like CPUs, they're not all created equal. So how a CPU is created is it's created on these circular silicon wafers, and in the process of making these individual chips, just like any manufacturing process, you're going to have issues and defects and, whatnot. Sometimes you're going to have perfect examples of the same thing. Other times you're going to have some with minor defects, and so on. So, for example, you might have, in this process of making CPUs, you might have a defect where, say, some of the cores on the system, the printing process of them got messed up and the cores just can't work. So in this case, if the CPU in general still works within more or less the spec, what manufacturers will do is they'll bin the chip and basically make it just a lower spec chip. So you can think of this kind of as your Intel i3s, i5s, and i7s, and even i9s. So like the cream of the crop, the perfect chips would be like your i9s, and the ones that might have some minor defects that have, say some cores that had some issues during the manufacturing process, that aren't, quite up to spec, they can tune those chips down and disable the cores that don't work and, sell those as, say the i3 chips, for example. And that's basically the point of binning, so you don't have to get rid of everything. Even the chips that you make that have issues, you can still manage to sell those, so you're not at a complete loss. Which if you think about it, makes sense. In addition to paying for more performance, you're also paying for a higher cream of the crop chip, and those don't come as often as some chips with defects. So it makes sense why those chips would be more expensive. So if we go back to the Apple example, when Apple first released their M series chips with the M1, they had a 7-core and an 8-core GPU variant. And this is exactly what you'd expect. This is the binning scenario right here. The 7-core GPU is the binned one, and the 8-core GPU is the full-fledged good to go one. So basically, in this instance with the M1, you would have, say, one GPU core in this instance that either was defective or overall just wasn't up to spec. So they just disabled that one GPU core and had it only run on 7 and sold it as that kind of chip. So basically, that's the other thing too. Chips don't necessarily have to have defective cores, but sometimes they're just able to run at, say, higher clock speeds, which is basically how many operations it can perform in a second. So some are just able to, perform better and faster, and they'll be, higher end, and the ones that can't perform as fast will then be brought down to be a lower end CPU. So then if we look at the chips that were just released with the M2 chips, those had a 10-core and an 8-core GPU variant. So this is the same thing. You have the 10-core GPU, which is the full-fledged, good to go, full spec, no issues M2 chip, and then you have the 8-core GPU model, which is the one that has the binning applied to it. And there was actually some good analysis by a few people, a few reviewers, when they were going through the M1 Pro, M1 Max, and M1 Ultra chips, where if they would take a look at various monitoring softwares, and you could see that all the GPUs were there, but they would show up as disabled, because that's exactly what's happening with these bin GPUs or bin chips in general. So yeah, just because a chip has a defect in it or can't hit the same clock speed, that doesn't mean the manufacturer has to throw it out. They can just make it into a lower SKU and sell it that way, so they don't, aren't completely out of money. So that's binning. So the next idea or concept that I wanted to cover is this idea of MBSE, which is alphabet soup for model-based systems engineering, which personally I hate it. Mainly, I guess part of the reason is I've had bad experiences with it and bad experiences with systems engineers as a whole. But that's where the rant comes in. But let's get into, what is model-based systems engineering and why people use it. So it's basically a way to create models of systems. So you can think of this as creating a model for financial systems to kind of, say model the stock market, for example, which is really hard to do. And if you're holding stocks in the stock market and listening to this at the, when this episode's coming out, I feel for you. RIP. It's a big oof right now. But, it's probably a very complex system, but, you'd create a model that could, kind of simulate, how the market moves based on, certain inputs like interest rates and GDP and, what all goes into a financial model. You could also do this for like weapons too. You could give it like sensor inputs for, like maybe a radar or something, and then how it moves and fires and all that stuff. You could also do it for people. Insurance companies, if they see like, oh, you're a male that is under the age of 25 and you own a sports car. I'm going to charge you more money because you're more likely to get into a crash and make me pay money. So I'm going to charge you more. Things like that. And then some other things that they would do for people like credit checks, like if you don't have a credit score, trying to gauge how creditworthy you might be based on some of personal factors, I guess. And then, sports games, like, you have your Madden and NBA 2K and MLB The Show, I think is what it's called. And, all these sports games, you have to create models for how the players play, how they interact, all that kind of stuff. So there's a lot of examples of where you can make models like this and why they would be useful. And it's basically the idea of creating these models is basically a way for engineers to have a common language to be able to communicate with each other. Now, another reason why this is really popular is because if you use like this model-based idea, it creates, and pretty much any kind of systems engineering, you make just a ton of documentation, which makes it really, especially in model-based systems engineering, if you have a model that depicts exactly how a system's going to work, you can easily show that, to a higher up, to a upper level management, someone in the C-suite or a senior vice president or, whoever, that either might not necessarily be as tech savvy or just doesn't necessarily have time to get into the weeds of how the thing works. They can look at these diagrams and look at these documents and get an understanding of what's going on and how the system works. So those are some of the big reasons why it's pretty common and why people use it. Now, let's move on to reasons why I personally don't like it before I kind of get into my little bit of a rant here. So one problem is it locks software developers into coding to the model. Now, depending on who you are, that could be a good thing or that could be a bad thing. If you don't really know how to code necessarily and you want everything done for you, then it's a pretty good deal. All the hard work's done for you. You're given a piece of paper or a PDF or some kind of document on your computer that tells you exactly what each thing's supposed to do, and you just have to code it up. Pretty easy. Problem is, if the systems engineer or whoever made the model messed up somehow, you're kind of stuck because you can't just fix it and do it the way that would make it work. That's not how this whole model-based systems engineering is supposed to work. You're supposed to code it to the spec, but if the spec is wrong, you're still supposed to code it to the spec, even though it's wrong. And then you come back to it later and be like, yeah, so this doesn't work, and then they have to basically go back to the drawing board, redo it, come up with a new model, give it to you, and you can recode it. Which, just by me saying that, you should kind of get the sense is, well, that would take a lot longer, wouldn't it? And yeah, you're right, it would take a lot longer. It does take a lot longer. So, yeah, if the model doesn't work, and you're as a software developer, you're kind of out of luck because you have to, because from experience and whatnot, coding something that you know is wrong is painful. Like if you know something that you're coding is wrong or won't work or isn't the best way to do it, it really hurts to code that because you want to do it the right way, but you can't because you're kind of stuck. So this is kind of the issue. Another thing with models is it's good, to have this, idea fully planned out, which I'm going to kind of get into another segment here where I kind of get into some irony about this. But it's good that you have everything planned out and everything's documented, so it's really easy to, code it up. But the problem is because everything's done ahead of time, you kind of lose agility. Like you can't just say, oh, we need to add this feature, let's go add it. No, that's not how it works. Systems engineers have to go back to the model, figure out how this new feature is going to fit in the model, add it, update everything, and then send it off to the software developer to go ahead and implement. So something that I could have been like, oh, I need to add a function here that's not in the model that can say track a player's speed running down the field, right? I could, have that done in, less than a day, maybe a couple hours tops. But if we're doing the model-based systems engineering way, no, we got to go back to the drawing board. Okay, let's see, where in the model can we put in the function? Okay, so we put that in here. Okay, now how does that affect the overall model of everything? And it's just such a pain. There's so much overhead, and you kind of lose that agility, which is kind of the point of, this idea of, in another software development buzzword, agile. Which is a whole software development process, which we're not going to really get into here, but basically Agile's this, way of developing where you have these things called sprints, which are basically 2 to at most 4, but generally around 2 to 3 weeks of development time where you have a set number of tasks that you're going to accomplish, and then you code those tasks up and go from there. And you kind of have this ability to be flexible. If you finish all your tasks, you can go pull another one in and, do all this stuff. So, but if you're doing this model-based systems engineering and have to always go back to the drawing board when something gets messed up, kind of really, really slows things down, to say the least. So just trying to add something simple, some simple feature that wasn't in the model could cause a complete rework or rethink of the whole model and make you redo the whole thing, especially if it's like at the very core of the model that everything builds off of. Now, I mean, if it's part of the model that's on like an edge case, like a tree, like a leaf of this tree that doesn't really interact with anything, then sure, it's, it should be pretty quick. But if it's something down at the base of the model, that could be a problem, which is kind of gets into my next point about scalability. We've been kind of hinting at this idea of having to, rethink the model and kind of go back to the drawing board. So imagine you have this gigantic model of a very, very complex thing. If you have to add some small feature, and you have to cause a complete rethink of the model, that's just going to take an astronomical amount of time, having to go through that entire model, figure out where this feature fits in, and how adding this here affects everything else in the model. It's just not scalable. And then you get into another problem where if, say, you're 80% done with the model, and then you realize, oh, shoot, we did something wrong, and you have to go back and redo the whole thing, which is not good, not ideal, really slows down development time. Whereas, say, you were just writing a piece of software that you were 80% done with, and then you realize you made a mistake, like in a function or something, you can just easily recode that function and you'll probably be fine. Sure, depending on the function, you might have to go back and like rename some variables. If you're using a language that makes you actually define variables, like, a C or C++, Java, something like that. Because say you were returning an integer and now you're returning a double or something, then in that case, you might have to go back and, find where you're calling this function and make sure you're setting it to the right kinds of variables. But at worst, that would take you maybe a couple days to fix. If you have a really, really big code base, maybe a week. But, with a model, having to redo an entire model like that, you're talking weeks at least, if not longer, to have to redo something like that. And then kind of another thing, kind of to build off this, if you don't know something for certain when you're building a model, you're kind of screwed because you'll have to eventually kind of redo it all, like we've been kind of talking. When you realize that you're wrong, you got to redo it all. But if you're programming it, you can even put in dummy values into your functions so the program still works. And then when you finally figure out what you need to actually put in there, then you can go back in later and, flesh out that function. And you can just, implement it later. Like, for example, say you realized the function that you were trying to do your math, the math you did was wrong. Like, so say I was calculating the trajectory of the football when the quarterback throws it to the receiver, and my math was just completely wrong. Really, everything else stays the same. It's just my math is wrong, so I just have to tweak the math in my function, and everything works as it should. It's not like, oh, in the model, I messed something up here, so now I have to go redo this whole section of it. Like, you don't, that's just not a thing if you're just working with software. And kind of like this idea of, just fixing one function. The effect of the overall code base is very minimal, and it realistically wouldn't take that long to fix. And probably, I would say most cases, obviously you have some cases where it probably would take a while to fix if you have a big code base, but in reality, it's probably not as hard. There's this thing called Control F or Command F if you're on a Mac. It helps you find things. So you can just find the instances of it and change them pretty quickly. So unless you have like some super core difference that you have to kind of do a code rewrite, that wouldn't really be an issue. But even if you have to do a code rewrite, which I've had to do that a couple of times, Depending on how big the scope of your project is, generally, I mean, that's obviously takes longer, but I mean, even that's not all that bad. Now, kind of going on to the ranty portion about systems engineers and why I don't like them. In my experience, they kind of don't seem to really care about the software developers. Now, don't get me wrong. I'm going to kind of rant about this, but keep in mind that it's not that I'm mad that I don't get recognition, because if you know me personally, you know that I handle recognition poorly, and I don't like being publicly recognized for things, and I personally kind of enjoy working behind the scenes. But just in my experience, systems engineers just kind of don't seem to care too much about the software developer. So one example I have is I recently had to give kind of a presentation to some systems engineers about how this simulation thing that I was coding and scripting works, basically. So I was just kind of I was going to give them a demo, be like, yeah, see, this is how it works, and then kind of go into the details of this is how, how it functions and kind of what's going on under the hood. Not like, go through my code with them and do like a code review, nothing like that. But basically just kind of walk through the steps at kind of a higher level of what the code's doing. So needless to say, we didn't talk about any of that stuff. I showed them the demo, and so they could, see the visual. And then I didn't even get to the chance to go over how the scripts behind the scene work before they just completely derailed the conversation and started talking amongst themselves about modeling for the remaining, I think, half hour, 45 minutes of the meeting. The meeting was an hour long. So, yeah. Good times. So in my experience, that's kind of been like a common theme that I've experienced, where if you get a bunch of systems engineers in a room, all they'll do is talk about systems engineering and modeling. And especially if you have like higher up people, like upper level management stuff, they'll get sucked into the systems engineering talk because that's kind of stuff they understand and vibe with, because it's easier for them to understand than you walking through like how the project or how the solution or the simulation or whatever you're coding actually works. Like, I mean, that stuff will kind of go over their head. Even if you do have like diagrams to explain it to them and walk them through it, they would still much rather see like, the visual of the model itself. So like, I kind of get that, but the thing that kind of just bugs me is, but this, let me take a step back. It's not, I guess, specifically the systems engineers. It's this idea of kind of wanting to have a meeting and bringing someone in for their expertise and then basically just ignoring them to talk about your own stuff. So another example of this would be, say I'm in the same role. I'm a software developer, and I have this prototype, and I'm trying to pitch it to the CFO, right? And all of his finance people to try to get some funding to, go further with this, because I think it's a project that'll help the company. So I get through the prototype, I show him the demo, and then I don't even get to talk about, how it works or how it could maybe even save the company money or make the company money and kind of how it works or anything like that. I just show him the demo, and then him and all of his finance people start talking about company finances and money and, where they could get money from and how this could affect the bottom line and all this stuff. And they don't even let me talk and give my part of the spiel. Like, what's the point in calling me in and having this meeting if you're not even going to let me tell you what I was going to tell you and what you wanted me to tell you? Like, it seems like you're not only wasting your time, but you're also wasting my time. And as far as the systems engineering perspective, going back to this, why bother calling in a software developer to talk about how their solution fits your criteria after you see the demo that they show? You just kind of forget that the software developer exists, and you just go amongst yourselves talking about, the model and the model this, the model that, and how can we do this and how can we do that, and you just completely ignore everything that they were gonna, tell you about how it worked, which might have even answered some of your questions, for all I know. But the idea that you call in a software developer, which the point of the software developer is to implement their model and make their modeling dreams a reality. I have this in, the sparkle, like the SpongeBob meme where he has like the rainbow, that meme, kind of thing of that, making their modeling dreams a reality. So you call the software developer in that makes your modeling dreams come true, and you basically waste their time calling them into this meeting where they were supposed to give you insight, and you basically just ignore them, but they still have to be there. Like, it's a completely different matter if you have a meeting, say, to talk about systems engineering, and you call in a software developer to kind of get their input and just kind of, have them there in case you need them. That's one thing. That's completely different than what we're talking about. What we're talking about is when you call in a software developer to demo their software and explain to you how it works, you let them do part of their job, and then you cut them off and just kind of go about your own thing, talking about what you want to talk about. I mean, that's just a waste of time, in my opinion. Wastes my time. I could have been off actually doing real work rather than sitting here listening to you, blabber on about, random model stuff. So that's my rant. Systems engineering, model-based systems engineering, personally not a fan, but it is a good segue for sure into this next idea of documentation and the irony of documentation and kind of the hypocrisy of documentation that software developers have, which I will give credit to the systems engineers. They are very good about creating a buttload of documentation. But most software developers, myself included, hate documentation. We hate making documentation. We hate making diagrams. We just want to code. That's what we want to do. That's what we're good at. We don't like making documentation. But the funny thing is, we hate it when there's no documentation for the code base or the software or the framework or whatever that we're trying to work with. We hate when that happens, yet we hate writing it, which is kind of the irony. We hate writing it and hate having to make it, but we hate when it doesn't exist. So it's got to come from somewhere, right? But we just don't want to be the ones that do it. Which I will say, like, personally, I don't mind too much, like, writing up comments in my code about what my code does, because that's almost as much as it is for someone coming after me, it's also for myself too. So in, 6 month time, when I come back to this code, I don't completely forget what I was doing and have no idea how something works and have to reread through all the code to figure out what's going on. I can just kind of skim the comments that I wrote and remember what I was doing. Like, oh yeah, that's what that function does. I don't have to go through and be like, okay, so I'm doing a for loop, and then I'm checking to see if that number is greater than that, and then I'm checking if this Boolean is set to true. Oh, okay, I see what I'm doing. I can just, read the comment that says, yeah, this is what we're doing. We're checking this. Cool. But as far as other things are concerned, like making block diagrams and class diagrams and control flow diagrams and sequence diagrams, I do not like that. It's annoying. And I'll tell you one thing, if you go through like any kind of degree in computer science, they always tell you when it comes to documentation to do the documentation first. But let's be honest, in the real world, the documentation is kind of an afterthought. At least in my experience it is. So you'll basically finish the, whatever your section of the code or whatever, your piece of software, and then you'll go in afterwards, after you finish all that, and add the comments and create maybe some diagrams. And usually what I've noticed how it comes in is like, it'll get to the point where you need to present your code to someone, and you're like, oh wait, I don't actually have anything to present them that isn't just, the code itself. Well, guess I gotta make up some diagrams, and that's kind of how it goes. Where it's kind of this afterthought of a thing, which I guess it really shouldn't be an afterthought, since if you have the documentation beforehand, it can help you write the code itself. But you kind of run into this conundrum of which is faster. Is it faster to go through, kind of going back to the model-based systems engineering topic, is it faster to go through and think out every little detail of the code and diagram it out, graph it out, go through, make sequence diagrams of everything, make class diagrams of everything, make an entire design document, and then implement it, and then realize some things don't quite work, and then you have to modify things kind of as you go? Or would it be quicker to just kind of get a basic sense of what you're trying to accomplish and then implement it? Because at the end of the day, I don't care how good a software developer is when they're making documentation. If they're doing the documentation beforehand, they're going to run into issues that they didn't account for or didn't plan for or wasn't in the design document or any of the other documents, and they have to code it up on the fly and figure it out and debug it. So it's kind of this idea of which is it really worth the time to do all the documenting beforehand to make your life easier down the road, or do you just kind of struggle through it, push through it as you go, because at the end of the day you still have the same finished final product, except in the first case you do a lot of work up front, and then theoretically the actual coding part goes a lot smoother? Or do you just, hammer out the code and just go ham on it? For me, I think it definitely depends on the scope and size of the project, for sure. If the point of your project is like a really small thing, or you're writing a script, doing the documenting before, you're just wasting your time, in my opinion. It'd just be quicker to code it yourself and hammer through the problems as they come. But if you're writing a really big thing, like say you're writing an operating system, for example, which I get is, a stretch and not necessarily a common use case. But something like that would definitely, you'd want to, at least have some kind of design of how things are going to work beforehand, because trying to code that from scratch with no plan whatsoever, good luck. So it really depends, I think, on the size and scope of the project. But I guess you have this other question of how much documentation is enough and how much is there such thing as too much documentation? Because there's definitely such thing as not enough documentation. That's for sure. But I think it also, again, comes back to the scope of the project and the use case of the project. So, for example, if you're creating an API or some kind of framework that other people are going to be able to use and tie into, you're going to want a lot more documentation for that so people actually understand how to use it and how it works, compared to, say, if you're just writing an application that is only going to be used by an end user. So if you're only writing something that's going to be used by the end user, you don't really have to worry about going super in depth and documenting how this class talks to this class and how this function interacts with this function over here and all this nitty gritty stuff. If you're writing like an API or something, you probably need to do a little more of that, so when the person's using it, they actually understand what function they're using, what it's actually doing, and what data they're getting back. But if you're just writing something for an end user, I mean, you basically just have to write, this is how the program works. This is, if you want to do X, you do these steps. If you want to do Y, you do these steps, that kind of thing. Which the majority of my programming has kind of been along those lines. Most of the stuff like on my GitHub, for example, is pretty much along those lines. And for that, I think if you got some like documentation like in the code itself, like with some comments, for example. So if someone actually goes through and wants to use your code, they kind of get a sense of, what's going on. And then you have some kind of like README file or something kind of documenting like how to actually use the program. In my opinion, that's more than sufficient if you're writing a program for like an end user. But if you're writing some kind of, like I said, like a library or a framework or an API or something like that people are actually going to use and tie into their own code, then you're going to want some more documentation about how things actually work. But again, it kind of goes back to the size and the scope of the project determines how much documentation you need. But again, there's still the irony of software developers, we hate writing it, but we also hate when it doesn't exist. The irony. So the last thing that I want to talk about is Homelabs. Should you have a home lab? What are home labs? And kind of my thoughts on them. So basically, I guess we'll start with what is a home lab. So a home lab is basically this environment that you have in your house where you can pretty much play with technology, hardware, software, gain experience on new things, or enhance better your craft and other things that you already know. So for example, say you wanna learn how to create and manage virtual machines, for example, say on a hypervisor like VMware or Hyper-V or Proxmox or something like that. What you can do is, you can, in your home lab, you can, set that up and play around creating VMs and, managing your stuff. And it's a great way to learn. Another thing you can do with home labs is you can basically beef up and pimp out your home network. If you're old enough to remember, there was a show called Pimp My Ride. Pimp my network, make it all nice and fancy and hot rod it, make it all awesome. So this could be anything from you have your own router running with something like pfSense, for example, which is basically like basically just kind of, you don't have, not to go into details of what it is, but it's basically its own router software. So rather than using that thing that your ISP gave you, you basically have your own essentially and run it on your own hardware. So you could do something like that. You could have your own VPN set up. I know in one of the earlier episodes of the Dark Assassins podcast, we talked about VPNs, specifically why VPN companies are lying to you. But we also talked about kind of what they are, and why I use them and why I personally like them, because, it allows me to connect back into my home network from anywhere in the world, as long as I have an internet connection. And I can manage my home network. I can get my ad blocking capabilities through Pi-hole, which is another thing that you could do in your home network, in your home lab. And yeah, it's definitely great. So going back, you could have something like Pi-hole, which is a DNS system, which is a domain name server, basically, where rather than, well, you can configure Pi-hole in two ways mainly. You can have it where Pi-hole reaches out to a DNS server like it normally would, like say Cloudflare or Google's DNS, to basically figure out where you're trying to go and give you that location. Or you can set it up as a recursive DNS, which basically means that Pi-hole will reach out to the root of the domain name. So say you're trying to go to apple.com, it'll, instead of going to say Google's DNS server, it'll go to the .com DNS server, which is the main DNS server that houses entries for all .com addresses. And then it'll basically work backwards all the way until it gets to, in this case, apple.com, and then give that back to you. Which, if you're looking for a more privacy-centric, that's definitely the way to go. So not all of your DNS queries are going through one person to kind of figure out what you're doing, which I think I mentioned in that VPN episode, this idea of DNS leaks, where if you're going through a VPN, but you're always going to the same DNS resolver, like say your ISP has your internet service provider. They have their own DNS system. So if you're going to your ISP for DNS requests, they're going to still, it doesn't matter if you're using a VPN or not, they're still going to, what websites you're trying to request and kind of be able to get you that way. But if you're using a recursive DNS, like with Pi-hole, you're not always going to one place to get your DNS queries. You're going to different places to get your DNS queries, which is very cool. So there's definitely a lot of uses for Homelabs. You can play around if you want to and go real ham. You can play around with malware too. Although I think it definitely goes without saying, if you're going to have a home lab where you play around with malware, you better have that bad boy locked down tight, so that malware can't get out of that enclosed environment and infect other things, because that is definitely not a fun time. Don't want that to happen. So if you're going to play around with malware in your home lab, make sure that everything's locked down tight and everything's secure. And not just double check it, but triple check it, quadruple check it. Make sure that nothing can get out of that virtual environment. So I guess another thing that comes when people think about home labs is, well, how much does it cost? And that's a very good question. So really, it's pretty much like any hobby, if I'm being honest. You can not spend much money, or you can spend a ton of money. Like, you could go as cheap as, like an old laptop or desktop that you have lying around that you're not using, or you could go as ham as you have an entire data center that acts as a space heater in the winter, so you don't have to run your heat at all, and you lower your heating bill in the wintertime because how much heat that thing's putting out, and you have tons of enterprise hardware and all this stuff that costs thousands of dollars. So pretty much you can go as ham or as little as you want. Me personally, I started out, I didn't use like an old computer or anything because I didn't have one at the time. But what I did was I ended up buying like one of those cheap Dell Optiplex, like old business desktops. I think I was looking on eBay the other day for them. You can find these things for like $100 or cheaper. I mean, they're dirt cheap. So you could buy something like that. You wouldn't even have to throw in any extra RAM necessarily, depending on what you want to do. If you're just trying to play around with software, for example, heck, as long as you got an old cheap computer, you're probably fine, as long as you don't necessarily care about, super quick, snappy performance. But if you threw a cheap SSD inside one of those things, you'd probably be set. But if you wanted to deal with like virtualization or something like that, then you'd have to make sure you at least have some processing power, since you'd be dividing up that machine's resources to be able to play with virtual machines. But even then, you don't necessarily have to, go super ham if you want to get into it. And what I would recommend is if you're just, starting to get in, or you want to get into home labbing, but you don't have a lot of money necessarily, if you don't have an old computer, I'd buy like a cheap one off eBay just to kind of get your feet wet and kind of play around with some stuff. That's what I did, like I said. And then if you figure out you like it, then you can, make upgrades down the road. That's kind of, that was basically my journey with home labbing. I started out with this, like I said, this old Dell Optiplex business desktop that I used. Played around with that for a while, and then I got my own network switch, so I could attach more things to my network. And then I built my own server, which, it wasn't all that much to write home about, but I built my own server because it was cool. I thought it'd be cool and fun, which it was a fun time. And then over the past couple years, I've actually gone out and bought some old used enterprise hardware for fairly cheap, which I will say, if you're willing to work with like slightly older hardware, which it should be noted, even though there is some old enterprise hardware out there, that's not to say that it's trash. Like there are some definitely good machines out there that are old, like enterprise servers. One thing to keep in mind though, if you do get into old enterprise gear, you probably want to have like, if you don't have a dedicated rack, which is like a thing that they use in data centers to put servers in. If you don't have a dedicated rack and a dedicated place to put that, where you don't have to be in the same room as it, that's probably the best, because some of those enterprise servers can get really freaking loud. Like I'm talking, it sounds like a jet engine is taking off loud. And sometimes that's just their idle speed, like, going without actually doing any work. That's not even the fans ramping up. So that is one thing to keep an eye on if you do want to go with enterprise hardware. If noise could potentially be a factor, something to keep in mind. But, I definitely recommend that everyone get into it. It's definitely a fun hobby, especially if you're trying to learn new skills or sharpen your current skills. Or or just learn technology, learn hardware, that kind of stuff. It's definitely great, and doesn't have to be reserved for the tech nerds and us nerdy geeks out there. So yeah, if you enjoyed this episode, I ask that you leave a rating and review, and subscribe to the Dark Assassins podcast if you haven't done so already, and be sure to share with a friend or family member who you think might enjoy this episode. If you have any questions about this episode, or you have any questions that you want me to answer to end up in a future episode of the Dark Assassins podcast, leave either a rating and review with your question in the review, or you can just shoot me an email at contact@darkassassinsinc.com. There's also a link in the show notes below that you can click on that, and it'll open up an email for you to send to me there. And that's going to do it for me in this episode of the Dark Assassins podcast. Until next time, my fellow assassins, remember, bull nothing equals true. If action not equal to null, return true. I'll see you next time on the Dark Assassins podcast.